Hello, sir. Can you hear me, sir?
Yes, sir. Jebin, sir.
Yes, sir. Yes, sir. I am asking to our expert, sir, whether.
Okay, sir. Okay, sir. English.
சார்
சாரோட வாய்ஸ்லாம் ஆடிபிள் தானே செக் பண்ணிட்டீங்கல்ல?
டவுன் செக் பண்ணிடுங்க சார்.
சார் சாரோட வாய்ஸ் நாட் ஆடிபிள் சார்.
Wait, sir. We will look into the problem, sir. Sir, Christopher,
Okay,
sir.
Okay, sir. Okay, sir.
Okay.
Hello, Christopher, sir.
சார் அதான் சார் பேசுகிற மாதிரி தெரியுது, வாய்ஸ் கேட்கலைங்க சார். ஜெபின் சார்.
Okay, sir. Okay, sir. I will look into it. So participants, so this is some of the general instructions I would like to give before starting the session. As you all know that in this Google platform, there is no separate provision for controlling all others. So I request all of you, please mute your audio as well as video. And as well as please don't click on the present no screen. So that will be very helpful for us to have our program in smooth manner. So within few minutes, we'll be starting the session. There is some small technical issue, so please bear with us. Thank you. Not audible, sir.
ஜெபின்
Sir, hello.
சாருக்கு மொபைல்ல கால் பண்ணி கூட செட்டிங்ஸ்லாம் வந்து என்ன, அதாவது எப்படி பண்ணிருக்காங்கன்னு சொல்லி கேட்கலாமா சார்? அவங்க
இல்லைங்க
மைக்லாம்
சார்,
வந்து
ஆல்ரெடி எல்லாமே இது பண்ணிட்டோம் சார். எல்லாமே நேற்று எல்லாம் இது பண்ணியாச்சு.
ஒரு
அது
ட்ரையல் எடுத்தாச்சுல்ல?
ஆமா, ட்ரையல் எடுத்தாச்சு. அவரோட அந்த இதுல ஹெட்ஃபோன்ல கொஞ்சம் ப்ராப்ளம் இருந்தது.
ஓ ஓ
அது
ஓ
கொஞ்சம் லூஸ் கான்டாக்ட் இருக்கு. அது அவர் சரி பண்ணிடுவார், ஒன்றும் ப்ராப்ளம் இல்லை.
சரிங்க 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 சார், சரிங்க
ஓகே,
சார்.
தேங்க்யூ.
தேங்க்யூ சார்.
ஹலோ ஹலோ
சார் சார் ஹலோ
ஜெபின் கேக்குதா?
கேக்குது சார். ஜபின் சார், ஐம் குருராஜ் சார். கேக்குது சார். ஹலோ
ஹலோ சார், குருராஜ் சார்.
இப்ப திருப்பி சார் இப்ப ரெண்டு தடவை பேசினாங்க, அது டக்குன்னு திருப்பி கட் ஆயிடுச்சு.
சார் உள்ளுக்கு வந்த மாதிரி தெரியலையே. ஓகே சார், நான்
உள்ளுக்கு வந்த மாதிரி தெரியலண்ணா.
ஆமா
சார் வாய்ஸ் தான் கேட்டுச்சு.
சரிங்க சார், பார்ப்போம் சார், செக் பண்ணி.
சரிங்க.
Hello, sir. Hello.
Hello, sir. I can hear you now, sir.
Okay. Now you can start.
Okay, sir. Okay, participants. Now I think we can formally start the session. Good morning to everyone present here. It's my pleasure to welcome you all on behalf of Ramco Institute of Technology, Department of Mechanical Engineering, for the second day of the webinar titled Design of Transmission System. I also would like to thank our management and faculty members for backing us for conducting this event. We are also very happy to have you all here today. So before starting the session, I would like to convey a few words about our expert who is present here today. Our expert is Dr. T. Christopher. He is acting as a visiting faculty in Anna University, Tirunelveli. And regarding his past experiences, he served as a vice principal and head of the Department of Mechanical Engineering, Government College of Engineering, Tirunelveli. He completed his BE Mechanical Engineering, GCT, Tirunelveli, as well as he also completed the ME Production Engineering in the same college, GCT Coimbatore. He completed his doctorate in NIT Tiruchi. He also have experience in industry as well as academic. He worked as design engineer in Toshiba Hivac, Chennai as project engineer. He's having more than 34 years of experience in academic and industrial sector. During his tenure, he published more than 50 journals. He also graded and completed 13 PhD scholars. He is also having more exposure in fracture mechanics, engineering design, composite structure, and finite element analysis, softwares like ANSYS, COMSOS, etc. Regarding his funded project, he also have completed many funded projects through TechCube for The cost of the TechCube project was around rupees 10 crore at GC Tirunelveli. He also obtained many funded projects like AICT Modrops. 3 times he has secured that project. One for CNC milling, another one for CAD workstation, another one for ANSYS software at GC Tirunelveli. He is also a member of many boards like BOG, Inspection Committee, panel members for interviews, which was recruited by Anna University. So this is a few short introduction I was thinking of giving to our beloved professor. He is also one of my Guruji. While I was doing my ME in Government College of Tirunelveli, I did my PG project under his guidance only. He's such a kind person. He's having vast experience in fracture mechanics and design subjects. So I hope this session will be one of the wonderful session and enjoyable session for you all participants. So I request all participants to gather much information from him. If you are having any doubt regarding his presentation, means you can ask at the end of the session. So with these words, I close my words and I hand over the session to our beloved professor, Dr. T. Christopher sir. Thank you. Sir, Christopher sir. Hello.
Sir, his mic is muted, sir.
Yes, sir. Yes, sir. Christopher sir, can you please unmute your mic, sir? Hello.
Sir, he's not in the webinar, I think, sir.
Wait, he's there, sir. Gold Frank. His name is Gold Frank.
Oh, sir. Okay. Wolf Frank. Okay.
Hello, sir.
Yes, sir. Yes, sir. Please proceed, sir.
Sir, yes, I'm starting. 1 second, I'll just.
Okay, sir.
So, good afternoon to all. I'm thankful to the management of the institution RIT, the principal, the beloved head of the department, faculty members, all the students who are now facing this webinar. This is a precious subject as far as I'm concerned. The design of transmission systems, which is a very dynamic subject, and once we say gears, it is always fascinating to students. In most of the places, in order to denote mechanical engineering, we use the symbol of gear. I'll just take a minute to share the file. 1 second. Sharing the file, is it given to me?
Sir, you please, I will stop my presentation, sir. You please click that present now button, sir. It is
Am
at the
I given
right
the
side.
right to open my share?
Yes, you can, sir.
Which is a tab present now?
Yes, sir. Present now, sir.
Present now, allow it in the screen. Okay.
Yes, sir. Yes, sir.
1 second. Can you hello.
Yes, sir.
Yes, hello to me. 1 second. Window and the screen could click on in the screen. இது press பண்ணு. இன்னும் அலோவ் பண்ணல போல இருக்கு தம்பி.
சார் அந்த ரைட் சைடில் ப்ரெசன்ட் நோ கிளிக் பண்ணோன்னே யுவர் என்டையர் ஸ்க்ரீன் அப்படின்னு சொல்லி ஒரு இது இருக்கு இல்லையா
இல்ல, வருது, பட் நெக்ஸ்ட் வர மாட்டேங்குது, ப்ரெஸ்ஸிங் வர மாட்டேங்குது.
இப்போ நான் கோல்ட் ஃப்ராங்க் ப்ரெசென்டிங்னு வருது சார். வந்துடுச்சு சார். நான் இப்போ கண்டினியூ பண்ணலாம் சார். ஓகேங்க சார். ஒரு பிபிடி தெரியுது சார்.
வருது. yes. Sir,
ஹலோ.
okay. See, yes.
Participants, I kindly request you to bear with us. So there is some few technical snag here. So I will soon rectify it and will get back to you. So please kindly bear with us. Sir, can you share your presentation, sir? Just to click on the present now button. Yes, sir.
Actually,
Present now.
Please, Jebin, mute பண்ணாதீங்க. You have to respond me, okay?
Yes, sir. Yes, sir. Okay, sir.
Okay. One second.
Yes, sir. Gold Frank is presenting the screen. Okay. Yes, sir. Now the presentation is visible, sir. Yes, sir. Now I think you can present the presentation, sir. You can minimize the screen and you can go to the presentation. தெரியுது சார். தெரியுது.
எப்படி see?
பிரசன்டேஷன் தெரியல சார். அதாவது உங்க அந்த இப்போ தெரியுது சார். கரெக்டா தெரியுது சார். தெரியுதுங்க சார்.
வீடியோ
நீங்க உங்க வீடியோ ஆஃப் பண்ணிடுங்க சார். அந்த உங்களோட ஸ்கிரீன் தெரியுது. ஓகேங்க சார். இப்போ ஆஃப் ஆயிடுச்சு. Hello, sir. We are able to see your presentation, sir. I think you can unmute your audio and you can continue on, sir.
குருராஜ் சார்.
சார் சொல்லுங்க சார்.
சார் கொஞ்சம் சார் கால் பண்ணி நீங்க கைட் பண்ண யாராவது கைட் பண்ணா நல்லா இருக்கும். ஏன்னா சார் வந்து பிரசன்ட் பண்ணி திருப்பி லெஃப்ட் ஆயிடுறாங்க.
சரி சார் நான் வரேன் சார்.
ஓகே.
Hello?
Yes, sir. I can hear you, sir.
இப்போ தெரியுதா? ஓகே. இந்த ஸ்க்ரீன் இப்போ ஷேர் பண்றேன்.
ஓகே சார்.
ஓகே ஓகே. அதான் ஓகே. ஸ்க்ரீன் வருதா பாப்போம். ஓகே.
ஓகே சார். ஓகே சார்.
எப்போ
இட்ஸ் விசிபிள் சார். விசிபிள்.
ஓகே ஓகே ஓகே. Audible,
Yes sir, audible sir.
Hello.
Yes sir, it's audible sir. Hello.
Hello.
Sir, it's
Hello.
audible sir.
Response,
Audible.
sir.
Hello. Hello sir.
ஹலோ ஷேர் பண்ணு.
ஹலோ சார்.
தம்பி இதுல பிரசன்ட் பண்ணமோ உங்களுக்கு ரெஸ்பான்ஸ் கொடுக்க முடிஞ்சா கொடுங்க. கொடுத்தா தான் எனக்கு நல்லா இருக்கும்.
சரிங்க சார்.
ஓகே
சரிங்க சார்.
நான் இது ஸ்கிரீன் கொஞ்சம் ப்ராப்ளம் பண்ணுது, அதனால தான். ஓகே நான் இது F5 போடல, இது வந்து ப்ரோசீட் பண்றேன். ஓகே நவ
இல்ல அப்படினா சார் நீங்க சார் நீங்க வந்து பிரசன்டேஷனை எனக்கு கூட சென்ட் பண்ணுங்க மெயில்ல. நான் வந்து ஷேர் பண்ணி விடுறேன் பிரசன்டேஷனை.
அப்படியே?
ஆமா.
அப்போ ஓன் பண்ணுங்க. அந்த லேப்டாப் ஓபன் பண்ணி இரு. மேலேயே அந்த கியர்ஸ் இருக்கும், ஒரு PDF இருக்கும். இந்த CS டேட்டா அது ரெண்டையும் இந்த நெட் யூஸ் பண்ணிடாத. அந்த நெட்டை யூஸ் பண்ணி ஜபிந்துக்கு அனுப்பி விட்டு பார்த்துருக்கோம். அடுத்த ப்ராப்ளம் தான். ஓகே
ஓகேங்க சார். நீங்க அப்போ கண்டினியூ பண்ணுங்க சார். நான் வரும்போது பிரசன்ட் பண்ணிடுறேன்.
ஓகே ஓகே ஓகே. ஐ அம் வெரி சாரி.
ஓகே
ஓகே. நார்மலி gears many types of the two elements will be looking as if they are gears to people. Now you see there are certain similar elements which look like gears. You see blower rotor, oil pump rotor, water pump rotor, gear pump, sprocket, but these are all not gears. Then what is gear? How is different from other things? Now the basic difference is the gear tooth is not very simple. It is a profile. It's a profiled structure. It has got a very special characterized profile. There are several types of there are few profiles which are used in practice. The most common is involute profile. When the tooth is involute with the involute profile, it is as gear. If it is not, there others. Even you have the sprockets, they are not involute profiles. Whereas in spur gears, we have the involute profiles. Where the involute profile is, that we will see bit later. Here you see the tooth are straight. The straight toothed gears are known as spur gears. When the tooth are inclined, when the teeth are inclined, they are helical gears. So what is the advantage of helical gear over spur gear is, spur gear there will be a single one or two pairs of teeth in simultaneous contact. That is, at the same time, one or two teeth only, pairs of teeth, one or two pairs of teeth only will be in mesh. In helical gears, more number of pairs will be in mesh. Therefore, moreover, from one tooth to one pair of teeth to another pair of teeth, entry will be very smooth in a wedged manner because it is inclined. And because of the wedged manner in the handing over, the handshake is very smooth, and therefore the operation is smooth. It is this we have the silent operation. But there is a disadvantage associated with the helical gear. Because of the inclined nature, an axial thrust will be induced in the shaft that is bearing the gear. There will be an induced axial thrust. Normally, the gears have basically one tangential force component is there, radial component is there. The resultant force is Fn, that is the normal force. Normal force has two components, one is tangential, another is radial. Whereas in helical gear, there will be an additional force known as axial force. This I will show at the end. And let's see the essential features of gear mesh. Now here, the center distance. Center distance is the distance between the two centers of the gear. Now, in order to alleviate the problem of helical gear, we can have two helical gears clustered together to form a herringbone gear. So, herringbone gear is nothing but double helical gear. One right hand helix, one left hand helix, they are clubbed together. And in this also we have the smooth operation, but the axial thrust is nullified. So, this is the way we can get the disadvantage of the helical gear. So, in short, helical gear or the best one is the herringbone gear, but the herringbone gear manufacturing is a bit complicated and costly. The pitch circle diameter. Pitch circle diameter is, this is the pitch circle. A circle almost passing through the center of the teeth is called pitch circle. The diameter of the that pitch circle is pitch circle diameter. Now, size of the teeth, size of the teeth. Here you see two teeth. The tooth has one tooth depth, that is with addendum and addendum, that is tooth depth. And it is wider at the base and narrower at the top. But along the pitch circle, if you see, it is a medium size, it is not off, but the medium size, this is the tooth thickness. So, but in overall the tooth has a size. ரொம்ப நாய்ஸியா இருக்கு, கொஞ்சம்
மேடம்
பண்ண முடியும்.
எந்த மெயிலுக்கு அனுப்பிச்சிருக்கீங்க, அனுப்பிச்சிங்களா? jbantk@gmail.com அதுக்கு போட்டீங்களா?
ஹலோ.
ஓகே ஓகே ஓகே.
Sir, you continue sir.
ஓகே ஓகே.
Jebin sir, mute your mic sir. Jebin sir.
கேக்குதுல்ல?
கேக்குதுங்க sir.
ஓகே.
கண்டினியூ பண்ணுங்க sir.
Next. Sir. Then the size of the teeth. So size of the teeth is important because the tooth depth and tooth thickness, they contribute size. The size of the teeth is also important in the design. Then we have number of teeth. Of course, the number of teeth can be counted. Then another very important feature is pressure angle of contacting involutes. There is difficulty faced by students where exactly is the pressure angle. எங்க இந்த பிரஷர் ஆங்கிள் மார்க் பண்றது அப்படிங்கிறது ஒரு டிஃபிகல்ட்டி எப்பவுமே வரும். It's a very clear presentation here. You see, there are two circles here. You see in the pinion, there are two circles. One is base circle, another is pitch circle. I'm yet to explain what is a base circle. I'll just come to this. Now, here in the wheel, this is pitch circle and this is the base circle.
வெங்கடேஷ் சார். ஹலோ
சார் குருராஜ் பேசுறேன், சொல்லுங்க சார்.
சார் நீங்கள் கொஞ்சம் இது பார்த்துக்கோங்க, நான் சார்கிட்ட ஃபோன் போட்டு பேசிட்டேன்.
சரிங்க சார், ஓகேங்க சார்.
பேசிட்டோம் சார், பேசிட்டோம். Participants are requested to wait some more minutes, sir, please.
ஹலோ சார், எது வரைக்கும் கேட்டீங்க? ரொம்ப நேரம் ஓடிடுச்சு நினைக்கிறேன்.
சார் ப்ரொஃபைல் எக்ஸ்பிளைன் பண்ணிக்கிட்டு இருந்தீங்க சார்.
ப்ரொஃபைல், இன்வெலிட் ப்ரொஃபைல்.
ஆமாங்க சார், ஆமாங்க சார்.
ஓகே ஓகே, 1 செகண்ட். One second. Right. Are you able to see the PDF? Is it readable?
No sir, no sir.
நோ சார்.
Readable இல்ல. Okay, okay. இப்போ readable-ஆ? Okay தானே?
No, sir. No, sir. No, sir.
நோ சார்.
Still you have to move, sir.
No
Okay,
sir.
okay.
Audible, not audible.
இது கேட்கல. Okay. Then I think I'll avoid this PDF. This is actually data book, but I am giving all the pages there in the presentation itself. I can make a note of that. Nothing else, no other way.
Okay, sir. Okay, sir. No problem, sir.
Okay. So the have I explained this second point, pitch circle diameters?
Yes, sir.
Hello.
That only. That only, sir.
Oh, okay. Pitch circle diameters, size of tooth. Size of tooth. This shows the size of the tooth. Okay, it has addendum, dedendum, that is tooth depth, and tooth thickness is this along the pitch circle. Face width is perpendicular to that. So all these contribute to the size of the tooth. This is an important feature of the gear. And number of teeth, of course, you can count. And pressure angle is the angle made by the line of action with common tangent of pitch circles. It will be confusing. You see, this is a pitch circle. This is pitch circle. Actually, these pitch circles are in contact. If this point is known as pitch point, I can draw a tangent, a common tangent to pitch circles, which will be through the pitch point only. Now, this is a cross common tangent to base circles. The inner circles are base circles. Base circles are nothing but circles where from invalid profiles are generated. So, the angle between the cross common tangent of base circles with the common tangent of pitch circles will be the pressure angle. We can get more detail from the further discussions. See, in the rack system, we can see the pressure angle more clearly because rack is having the infinite radius. Here you can see the pressure angle, which is normally 20 degrees in our Indian systems. 14.5 is also there. There are different standards. We normally follow 20 degrees. This is the nothing but semi taper angle of the straight sided rack. Now, law of gearing. Law of gearing is a common, here you see a common normal to the tooth profiles at their point of contact must, in all positions of the contacting teeth, pass through a fixed point on the line of centers called pitch point. I already indicated in the previous slide what is pitch point. Pitch point is nothing but the point of contact of pitch circles. Common normal is nothing but the line of action, which is the cross common tangent of base circles. Once again, you can see this is the cross common tangent of base circles that passes through this pitch point at all positions. So this is the law of gearing. Any two curves of profiles engaging each other and satisfy the law of gearing are conjugate curves. Conjugate means they are made for each other. That's the meaning. They are, when we have the pair of gears with 20 teeth and 60 teeth, they will be engaging with each other. That means the profile of the pinion and profile of the wheel are made for each other. So they are known as conjugate. If there is any non-conjugacy, there will be interference. You can just imagine in our friendship. Among friends, actually, one may be black, one may be white. I mean different types, I say. So whatever may be the thing, the friendship will be there. That is something about the conjugacy or matching of interests and matching of qualities, whatever it is. If anything is not matching, there will not be friendship. Like that, the gears will mesh only if there is conjugacy is maintained.
So sorry for the disturbance, sir. Sorry for the disturbance. So participants kindly click pin on the Jebin J presentation.
Oh, இப்போ வந்து இது ப்ராப்ளம் வந்தா அதன வரணும். அப்படியே அது இத கட் பண்ணி வெளிய வந்துறவா?
So no sir, you proceed sir, no problem sir. So by seeing your presentation you can proceed sir. Just Jebin this
presenting your screen sir.
அப்படியே ஓகே.
ஆமாங்க சார். நீங்க உங்க ஸ்லைட வச்சு அப்படியே கண்டினியூ பண்ணிட்டே இருங்க சார். ஜெபின் சார் நெக்ஸ்ட் ஸ்லைட் அப்படியே போயிடுவாங்க சார்.
இப்போ முன்னாடி ஓபன் பண்ணி விட்டாங்க ஜெபின்குள்ள ஓபன் பண்ணிச்சா?
நான் அவங்க ரெண்டு கொடுத்துருக்கேன் அது ஓபன் பண்ணுவாங்க.
சார் ஓபன் பண்ணிட்டார் சார். ஜெபின் ஓபன் பண்ணிட்டார். ஜெபின் ஸ்கிரீன் இங்க விசிபிளா இருக்கு சார்.
ஹலோ
சார் நான் ஜெபின் பேசுறேன் சார். அதாவது சார் இந்த நீங்க வந்து ஆஸ் யூஷுவல் நீங்க பிரசன்ட் பண்ணிக்கிட்டே இருக்கீங்க சார். நான் வந்து நீங்க சொல்ற ஸ்லைட வந்து நான் இங்க சேஞ்ச் பண்ணிக்கிட்டே இருக்கேன்.
அது பத்தி உங்களுக்கு தெரியுமா? நான் பண்றது உங்களுக்கு தெரியுமா?
தெரியும் சார். நீங்க அத ஆக்சுவலா அந்த மேல பீப்புள் அப்படின்னு சொல்லி ஒன்னு இருக்கு இல்லையா சார், மேல டாப்ல.
சரி,
அத பீப்புள் கிளிக் பண்ணீங்க அப்படின்னா அதுல ஜெபின் யுவர் பிரசன்டேஷன் அப்படின்னு சொல்லி ஒரு இது இருக்கும், ஒரு நேம்.
இதான் என்னோட பிரசன்டேஷன் வச்சு நான் பிரசன்ட் பண்ண போதும்ல?
நீங்க உங்களோட பிரசன்டேஷன் வச்சு பிரசன்ட் பண்ணுங்க சார். நான் எல்லாருக்கும் தெரியறதுக்காக நான் என்ன பண்ணிருக்கேன் அப்படின்னா உங்க பிரசன்டேஷனை நான் டவுன்லோட் பண்ணி ஷேர் பண்ணிட்டு இருக்கேன்.
இப்போ நீங்க உங்க இதுலயே நான் பார்த்து பண்றேன், ஓகேவா?
ஓகே சார், ஒன்றும் ப்ராப்ளம் இல்லை. நீங்க அதையே பார்த்து கூட பண்ணுங்க. நீங்க சொல்லுங்க, நான் மாத்திக்கிட்டே இருக்கிறேன்.
நீங்க கிளிக் பண்ண சொல்றது கிளிக் பண்ணுங்க. அப்ப 8 இப்போ 9th போங்க. நெக்ஸ்ட் 9th ஸ்லைட், 10th ஸ்லைட், நெக்ஸ்ட் ஸ்லைட். அது கொஞ்சம் F5 போடுங்க, அப்பதான் அந்த மூவ்மெண்ட் தெரியும்.
சார் கண்ட்ரோல் L கொடுத்துருங்க சார். ஜெபின் சார்.
ஓகேங்க சார், ஓகேங்க சார்.
நம்ம ஓடிட்டு இருந்த ஒழுங்கா தானே போயிட்டு இருந்தது. இப்போ முதல்ல நான் அனுப்பிட்டு இருந்தது பவர் பாயிண்ட் தெரியலையா?
இல்ல சார், அது கிளியரா இல்ல சார். அது
ஓ சரி சரி. இப்போ உங்களுக்கு அனிமேஷன் தெரியாது, இப்போ அது ஒரு ப்ராப்ளம் இருக்கு.
ஆமாங்க சார், அனிமேஷன் தெரியாது.
Okay, actually in the picture you see two black dots at the ends and the red dot at the point of contact. Okay, so the point of contact will start from here and end here till the point will be moving only along this line. So that is the line of contact. That is why it is line of contact. This is the nothing but cross common tangent of base circuits. And which point is not shown in this particular diagram? 11. Here this we have already seen. Here the nomenclature, you can have a look at here. What are the nomenclature of the gear tooth? Here you see the outside circle, that is also known as addendum circle. We have pitch circle here. We have this is actually the base circle. This is root circle. Base circle is an imaginary circle where from invalid profile is generated, whereas the root circle is the physically present circle where from the tooth is there. Tooth is supported. Here, if you want to find out the diameter of the pitch circle, it is module times module into number of teeth. Tip diameter will be module plus z plus 2. Module into z plus 2. Root diameter will be m into z minus 2.5. Next part. Pitch circle diameter for two meshing gears, there are the these are the diameters of the discs that would transmit same velocity ratio by friction if there was no slipping. So pitch circle, the meaning is it is imaginary. We can imagine two friction circuits. They are the pitch circles. Pitch circles are also not physically present there. They are the imaginary circle. You can think that those are the friction circles. 13. Module. This indicates the tooth size and is the number of millimeter of pitch circle diameter per tooth. For gears to mesh, their modules must be equal. Gear ISO standards and design methods are now normally based on the module. Gear module 3 has 16 teeth. Its pitch circle diameter is 48 mm. So module, once we say module, immediately people have lot of confusion, because module you cannot see in the teeth physically. Just like base circle and the pitch circle, which you cannot see in the gears, module also you cannot see. But I'll tell you a way how to see the module. You see the tooth depth, the tooth depth is 2.25 times module. Tooth depth is 2.25 times module. From that you can have an imagination. If you are given with the two gear wheels, if you see two different teeth, you can two different sized tooth. You can understand the smaller tooth will have smaller module. The bigger tooth will have bigger module. If you can measure approximately the tooth depth and divided by 2.25, you can get the module. I'll repeat. If you can measure the tooth depth approximately and divide it by 2.25, you can get the module. Otherwise, the exact procedure is measure the outside diameter and substitute in the formula the previously shown in the previous slide. That is addendum diameter equal to m into z plus 2. That is a tip diameter. So measuring the tip diameter, you can knowing the number of teeth, you can get the outer. I mean, you can know the module. I think it's fine to you. Next. Diametral pitch. It is an alternative measurement. Just like SI and CGS units and all. In another system of units, 1 by m is used. Like sometimes we use Poisson ratio. Some people use 1 by Poisson ratio. Just like that, diameter pitch is the reciprocal of module. Some people use that in designs. Circular pitch is the distance from one point on the pitch circle of the one tooth to the corresponding point on the adjacent tooth measured around the pitch circle. This is also not very important from our calculation point of view. This is just for an understanding. Next. This is a rack system. Why I am showing the rack system is the invalid profile in the invalid profile system, in a rack, these sides are straight. So for an invalid gear, it is very easy to manufacture a straight-sided rack. Clear? I'm going to tell 2-3 points. That is, it is very easy to manufacture a rack with invalid profile. Once you manufacture a rack, you can use the rack cutter to generate invalid profile gears. Understand? So rack cutter is one of the process. Using the rack cutter is one of the process by which you can generate invalid profile gears. So generation of manufacture of a rack is very easy. So for invalid gearing, racks have straight sides. That is the advantage. So rack cutter can be used effectively in manufacture of accurate invalid profile gears. So that is why I'm just showing the rack, because this is a very important point. Next. This actually, I meant, it's an animation. We are unable to see that. You could see, okay, you can, of course, you can, large number of animations you can see from the, okay. PPT, can you PPT load பண்ணலாமா தம்பி? It has been said. Or I can continue.
ஓகே சார், நான் இப்போ பிபிடி லோட் பண்றேன் சார்.
பட் இல்ல விடுங்க இதுக்கு அதுக்கு மேல ஒன்றும் பெருசா அனிமேஷன்ஸ் இல்ல. we can follow this. okay
ஓகே சார், ஓகேங்க.
அந்த பிடிஎஃப் கொஞ்சம் பிடிஎஃப் பண்ணிங்களா? பிடிஎஃப் ஓபன் பண்ணும்போது ஓபன் பண்ணிக்கலாம். ஓகே ஓகே தென் 17 பா 17. This is actually we have seen multiple times. I think it is clear to people. Just to recall once again, the base circles. Base circles are the circles where from invalid profiles is generated. You see, this is the invalid profile generated from the base circle. This is invalid profile generated from this base circle. They are away from each other, and the cross common tangent is the line of action that makes pressure angle with the common tangent of pitch circles. So this is the pitch point. Here you see this is the pitch point. I think it is clear to you. Next. So this is actually how invalid profile is generated from a circle. This is the, in first year graphics itself, people would have learned this. This is how you can generate the invalid profile. We have to divide the circle into a number of parts. If you know this caudal length, take that caudal length from here and cut it here. If you know the arc length, take that arc length in a chord and draw a tangent to this line. So that end of the point will be your point C1. I'll repeat for this. If you know this arc length, measure this arc length, take a straight line, draw a tangent from here, end of the tangent will be point C2. Like that C3 and all. If you connect those, you will get the involute. Next. Actually, this is the one video. You can share to students, they can see it later. You can see how the invalid profile is generated. Let them see it afterwards. You can share to the students. Next. Major advantages of invalid though. I'm going to go fast with 3 slides because the design procedure is there next. Conjugate action is independent of changes in center distance. It's a very big advantage of invalid profile is, even if there is a small change in disturbance in center distance, the conjugate action is not disturbed. Please, you can underline this. Underline this point. Actually, this point is, even if you change the center distance, conjugate action is not disturbed. Next, the form of the basic rack tooth is straight-sided and therefore relatively simple, can be accurately made as generating tool. It reports high accuracy to cut gear tooth. I have already explained. One cutter can generate all tooth numbers of same pitch. While cutting gears using milling cutters, not the gear generators, I mean the disc cutter of the invalid profiled disc cutter, when you are using it for gear cutting, you could have seen that for 20 to 30 you will be using one cutter, 30 to 40 you will be using a different cutter, because the tooth gap will be different for different numbered gears and different cutters will have to be used. Whereas in gear generation process, underline gear generation process, here a cutter can be used for all numbers of tooth because it takes automatically care of the tooth gap. Next slide. Next. Cycloid gear profile. It has got a particular advantage. Pressure angle remains same through the operation. It is easier to manufacture due to convex surface. Velocity is not affected to variation center distance. Teeth are weak. Interference takes place. Oh, okay. More wear and tear as contact phase between convex surface. Actually, there is inverted gear profile. Oh, actually, this is some repetition. Sorry. Please go to the next one. Cycloid. This is the cycloid profile. Cycloid profile, actually, we have very important. There is no interference. There is no interference, and it is stronger. The angle is maximum at the start and end. Teeth are stronger because it has a wider base. So that is a point to be noted. It has wider base, and then the teeth are stronger. And interference is very less here. Next. Contact ratio. Contact ratio is, so this is the angle through which the approach, that is the point of contact, takes place here, and this is a pitch point. Then point of contact move to that other end, this end, and this is angle of approach. This is angle of arc of this is arc of recess. Of course, angle can be measured from the center of respective gears. So the ratio of this ratio of arc of approach to the pitch circle total arc is contact ratio. The total total arc of approach plus arc of recess is total arc of contact. This divided by the total arc length is the contact ratio. Next. Backlash. So backlash, as soon as you hear the word backlash, we misunderstand because we always think that backlash is an error. Backlash is not an error. In instruments, backlash is an error because of use of gears or the threaded elements, there may be backlash in the threads or gears, and those backlash will induce some error. Hello?
Sir, 1 minute, sir. I am changing the presentation, sir.
Okay, okay.
Sir, I think it's clear now. I think there may be some animation also, sir. So this, I think it's visible.
This you can see, yes. So this is invalid profile. We will be using only a partly, very small part only will be using. Previous slide podunga. In the previous. Okay. This one actually rack will be sliding, but it is shown because it is rotating as it is rotating. Okay. We can go to the next, some 18th slide. 19, 21, 22, 23. Contact ratio. Contact ratio also we have explained. Now backlash. Backlash is actually the difference between tooth gap and the tooth thickness. I'll repeat. See, this is the tooth gap. This is the for this tooth. This is the tooth gap along pitch circle. Along pitch circle, we have to see this is the tooth gap. Whereas this is the tooth thickness. Just like the grinding stone. You can just imagine of that. Imagine that art ural, grinding stone. Adla pathina maavatrada palaya kalathula maavatrada paathinga theriyum. Ipo adu romba common illa. Kalla vandu அப்படியே உள்ள இறக்கிட்டு அப்படியே ஒரு கையில அப்படியே ஏத்தோ செய்வாங்க, உள்ள இறக்கவும் செஞ்சிருவாங்க, அப்படி ஃப்ரீயா உள்ள ஆடிக்கிட்டே இருக்கும். அதே மாதிரி தான் இதுல இருக்குது. ஆக்சுவலா அந்த டூத் வந்து ஸ்மூத்தா உள்ள இறங்கும், ஸ்மூத்தா வெளியே வரும். ஒரு ஆட்டுக்கல்லும் குழம்பு எப்படி ஒர்க் பண்ணுதோ அதே மாதிரி தான் ஒர்க் பண்ணும். அது ரெண்டு ஒரே டைமென்ஷனா இருந்ததுன்னா உள்ள வந்து ஃப்ரீயா இருக்க முடியாது. So tooth thickness is less than tooth gap. The difference is backlash, and because of that errors may be there. Whereas in gears it is a designed and machined feature. So backlash is difference between tooth phase and tooth thickness as measured on the pitch circle. It is not an error. It is a designed and it's been inscribed in the design. It is a part of the design. It is the purposely done feature. Next. Gear interference. Interference is something not matching. If the conjugate nature is missing, interference will be there. And the basic reason for the interference is, for economy purpose, we make smaller gear the smallest possible and to have the bigger gear. Whereas in mechanics and machine, you could have learned the minimum number of teeth we normally take it as 20. Even with 20, the interference is not actually not avoided. The reason is there is a circus between base circle and root circle. If base circle is far away from outer, if far outer than the root circle, the involute profile starts from base circle, and below base circle there is no involute profile, and because of that interference occurs. I'll repeat. Base circle, in one of the sketches I can show. In base, if base circle is much larger than the root circle, because the involute profile exists outer to the base circle, there is no involute profile inside base circle. Therefore, there is interference. So, in brief, in short, you can say non-conjugate mating causes interference, and because of that, the pitting or wearing all take place. I'll explain in one of the following slides. Next. So this is the undercut. Actually, when we have the interference, in order to avoid interference, we make some pitting, filleted part we can do. This is one of the way by which you can get out of the problem. But this is not a good practice because it will be weakening the gear. Next. Here you see, with the 12 number of teeth, this is the root circle, this is the base circle. With 12 number of teeth, this is far away from the root circle. Here you see with the 20 number of teeth, the base circle is closer to the root circle, and this is the difference. Here, if you use 12 teeth, interference will be very high. Here, if you use 20, interference will be less. I think this is very clear to you. Next. You see here, with the 39 number of teeth, for involutes is the base root circle and base circle will match. If you use this with the 39 number of teeth, interference will not be there. That is, out of pinion and wheel, you have to use minimum pinion as 39 teeth. So that is the meaning. If you use it out of 2 gears, supposing 139 is there, you are using pinion 39, wheel as 100, there will not be any interference because here the root circle and base circle coincide. Here you see the base circle has gone inside. Base circle has gone inside the root circle. Therefore, the profile will be totally involute profile. That's the meaning of the minimum number of teeth. Why we are going for minimum number of teeth? You can say that it is approximately 39 is the minimum number of teeth, which will completely avoid interference. Okay, next slide. See, these are the failures. When there is interference, extra pressure will be applied on the faces of the gears. That will create cracks, and you can see the interior fatigue fracture also. So these cracks will the pitting further develops into a crack and proceeds to inner teeth and it fails. Next. Here you can see this root failure due to bending. The gear tooth base fails because of the extra bending stress and fatigue. Here you can just simulate a point of contact at how the stress will be concentrated. Here the contact stress is there. Here it is stress concentration because of fillet radius. A sudden change of cross section from because of that. Because of the fillet radius provided, it is minimized. If fillet radius is not produced, infinite stress will be there. So this gives you the a small pattern of stress distribution in a gear. Next. Now we are coming to the design of gears. The students can refer to the design data book. Actually, I thought of showing the data book but it is not visible to the audience. But however, I have added all the page numbers here. So later on, you can use it as a record, because with the help of this, you can get everything. But now I'll explain one by one, and I'll repeat once more. I have divided the design of gears into 7 steps. I'm going parallel for spur as well as helical. Rendayum parallel da poren. Spur and helical. Step 1 is minimum center distance. So step 1 is minimum center distance. So this will take 2-3 minutes. Please patiently listen this, because this is the thing which is going to help you to solve problems. Center distance is a very important feature, because if you keep the center distance very small, forces will be very large. If you keep center distance very large, forces will be small, but economy is out. The gears will be very large, cost will be very high. So we have to keep the center distance the minimum possible, so that the material withstand the required compressive strength. So the formula, the center distance should be more than what you calculate from this formula. Here I plus or minus 1, cube root of 0.74 by sigma c within square bracket 4 square E mt within square bracket I psi. This is equation 1.1, which you see in the page number 8.13 of the data book. So what is different for helical and herringbone gear? Helical and herringbone gear, you see, what is different here from here? It is nothing is different here. I think almost the 0.74 instead of 0.74, 0.7 is used. Now what is I? I is nothing but the reduction ratio. Normally, always the reduction ratio will be more than 1. So reduction gears only we will be using the ratio. Normally we are using the reduction ratio, say 1 to 4 for a single reduction. Single reduction 1 to 4. So if I is more than 1, if it is a multiplication, that is a gear multiplication of speed, also we have to use reciprocal of that and have the value as more than 1. I will be more than 1. Plus is for external meshing, minus is for internal meshing. If you see the footnote of the data book, you can find it from there. Minus is for internal meshing of the gear. It is not available here. It is footnote of the data book. I mean, at the footnote of the data book, you can see that plus is for external meshing, minus is for internal meshing. 0.74 is a parameter given by the simplified design. Sigma c is the allowable compressive strength of the pinion. I'll repeat, sigma c is the allowable compressive or crushing strength of the pinion. E is equivalent Young's modulus of combination of material. We'll be using, if you are using two different materials, two materials will have two different E values. Those values are to be calculated like E1 into E2 divided by E1 plus E2 or something like that. The formula will be there in the page number 8.14. I am unable to show it here. In page number 8.14, you can see the formula for the equivalent Young's modulus. If both of the materials are steels, say C45, we are need not worry about it. It is always 2.15 into 10 power 5 MPa. And MT is the design MT, that MT within square bracket. So that MT has that is a twisting moment, for which formula is available, page number 8.15. Here by 8.15 you can see the formula. If you know the power and speed, you can get MT. But how to make it inside square bracket, that is design MT. So MT has to be multiplied by KD and K, a dynamic load factor and a service factor, KD and K. Those things are available page number 8.14 itself. From there you can take the values of KD and K. But normally, initially, we'll be using, we'll not be referring to anything. Initially, you are seeing KDK equal to 1.3. I repeat, initially assume product of KD and K 1.3. Similarly, psi is B by A. That is breadth, face width of the gear B divided by center distance A. That is a simplification factor. So B by A is psi. Initially, you have to assume psi as 0.3. So this recommendation, you can find it there in the page number 8.14. But without bothering much, you can use 1.3 because we are going to nullify the effect later by a simple calculation. So I repeat, what are the things to be MD? I told you how to calculate. Sigma C also, because of the, one second, next slide, Katpa. I don't know whether I am given. Next slide. Illa negra. Illa, right. Okay. Okay. So sigma C also has to be calculated. Sigma C depends on a life factor, hardness, rock wool hardness or brittle hardness. All those things are available in page number 8.16. By knowing the hardness of the material and a life factor and another correction factor, CR. If you are using rock wool hardness, CR will be there. If you are using brittle hardness, CB will be there. You have to pick those values and multiply that. You will get the sigma C within square bracket. Or for very standard material combination, they are given there itself, 8.5 or something like that. The combination, material combination is also given. You can directly even take it. But normally for examiners, expect that sigma C need to be calculated. Sigma C within square bracket need to be calculated. It is given by normally CB, HB, KCl. That is, CB is a constant to be picked. HB is brittle hardness of the material, that is the pinion material, and KCl is the life factor, which is normally 1. If you put all these values, you will get the value of center distance, say 9 centimeters. You have to be careful in substitution. Whatever the units recommended in page number 8.1, you have to use. I repeat, whatever the units recommended in page number 8.1 has to be used in substitution. Not E equal to 2 into 10 power 5. It may be 10 power 6 kg per centimeter square or something like that. Not millimeters, wherever possible, it is centimeter. Those recommendations you can see in the data book, page number 8.1. So once you get the center distance, say approximately 9 or 12 centimeters, you may get. With that, you proceed to the next calculation. Next one.
And sir, shall I show that data book also, sir? If required means I can show.
Open agada.
Open sir. 1 minute.
Open agina 14, 18 kattenge.
Page number, sir, 8.18. On that.
Just show it below, lower part. Oh, sorry. 8. This is KB, sigma B. 2 pages, 8.16 put it. 8.16. Sorry. 8.16. You see, this part only. You see, just scroll down. Here you see sigma C is either CB HB KCl or CR HRC KCl. If your material has normally carbon steels and alloy steels of any type which have hardness less than 350, CB can be taken as 25, and normally the value will be 216 or something like that. With that hardness, you can substitute here. You can get the value of sigma C. noisy. ஏதோ மியூட் பண்ணுங்க தம்பி.
சார்
ஏதோ கொஞ்சம் மியூட் பண்ண வேண்டியிருக்குது, நிறைய நாய்ஸ் வந்துருச்சு. பயங்கர நாய்ஸ் வந்துருச்சு.
இல்லையே சார், இப்போ கிளியரா தான் இருக்கு.
அப்படியா? இப்போ ஓகே.
ஓகேங்க சார்.
ஓகே, அந்த இதுல ஒரு 8.5 பேஜ் நம்பர் 8.4 or 5 காட்டுக்கு மெட்டீரியல்ஸ் லிஸ்ட் இருக்கும்.
ஓகே.
இந்த ஹரிசாண்டலா இருக்கு இல்லையா? In this page you can see that from here you can collect if you see the values, material combinations. Next page. You see, you can select the materials like this: pinion C45, wheel like this, and C50 is like this. Like this you can get the combinations, or you can take even C45 and C45 also. Next page. Here you see, for C45 sigma C is given, sigma B is also given. The precaution I am giving is you cannot directly take these values from these tables. I repeat, you cannot take sigma C and sigma B directly from these tables. Examiners will reduce marks. You are supposed to calculate using those formulae. Okay, then come to presentation. Okay, next. Here, we have to, next calculation is to calculate module, minimum module. Module is the another feature, important feature. Some noise irukku.
Sir, 1 minute.
Okay.
மைக் வந்து மியூட் பண்ணிக்கிறேன் சார் என்னோடத.
சரி. நான் இதை கேட்டீங்கன்னா ஓப்பன் பண்ணிக்கோங்க. ஓகே. Minimum module based on bending strength. This accounts for bending strength and endurance limit also. Module is greater than or equal to 1.26 cube root of square bracket empty divided by form factor y sigma b square bracket psi m z1. So this actually the module accounts for gear tooth thickness, gear tooth size. So here the bending stress is very important. Therefore the design bending stress comes in page number 8.18 in a similar pattern. The how to calculate sigma c, the formula are given. You need not bother about now. You can see it later because I have given the page numbers and all. Now sigma b you can calculate. Y is the form factor that is very clear given in page number 8.18, table 18. If you see the minimum number of teeth in the line, the 80 table number, page number 18 mattum konjam kaamukkum. Please show page number 18. Page number 18 top. top, table 18. Here you see, if you have the number of teeth 24, you see the form factor will be 0.414 for zero modification. We are not modifying the gear because modification is required for avoiding interference, but we are doing the basic design. Therefore, we don't bother about the modifications and all. So, if we have the minimum number of teeth, the pinion number of teeth 24, we have form factor 0.414. Clear? This can be closed. So sometimes there is a question: what is form factor? So these definitions normally you cannot find from the book. I'll tell you, the form factor is a factor that accounts for correction for tooth gap. Form factor is a correction factor to accounts for tooth gap, which depends on the number of teeth of pinion. That's all. That definition will be sufficient. You can give. If corrected teeth, for corrected teeth, the form factor will be different. For uncorrected teeth, we will have a value given in the table. Sigma b you have to calculate as I have explained earlier. Psi m is b by m. Psi m is nothing but b by m. This is normally assumed as 10. Psi m is assumed as 10 because psi m is given in page number 8.14. Recommendation is given in 8.14, but you can close your eyes and take 10. And Z1 is the number of teeth on pinion. Z1 is number of teeth on pinion. So this here is the place where you will be designing what is the number of teeth. Normally it may be given in the problem itself. If it is not given, you can assume 20. Helical herringbone gear, there is a small difference. The helical angle beta is an additional thing, which can be which is normally assumed as 8 to 22. 8 to 22, it varies. 8 to 22, we'll be using in an average 15 if it is not given. And form factor YV is same as Y, but we have to calculate for ZV. Here Z1 is given, but ZV we have to calculate using a formula given in the data book page number 8.22. Can you come one sec, please? 8.22. 8.22. Last but one page. Here you see, the top of ZV ZV you see virtual number of teeth equal to, for helical gear is it is Z1 by cos q beta. That's all. So for helical gear, you have to calculate Z1 by cos q beta. Once you know this value, table 18, you can recall table 18, use the same table 8.18. In place of Z1, you are using ZB1. That's all. Use ZB1, take the value of YV. YV table same down. And Z1 Z1V. That's all. That's the difference. Sigma B will be calculating as usual. Psi m will be assuming 10. Z1 will be assuming 20. Next. So this is just to demonstrate how the bending stress is taken. Derivation is that next column. Next. So next third step is to check center distance and round of module. Once you know the module and number of teeth, you can calculate geometrically. You can calculate the center distance. நிறைய students ஒரு mistake பண்ணுவாங்க. எடுத்த உடனே ஏக்கு இந்த மாதிரி ஒரு ஃபார்முலா போட்டு கால்குலேட் பண்ணி வச்சிருவாங்க. That is erroneous. This is only a geometry formula. This is not the design formula. Students, please note that this is a design. This is not a design formula. This is the geometry formula. After step 1 and 2 only you can come to here, come to this place. You can calculate A from the calculated module. If the A is more than what you have calculated in the step 1, I repeat, if the calculated A here is more than the A calculated from step 1, your calculation is ending here. Therefore, you can round off the module in mm from table 1, page number 8.2. நான் ரிப்பீட் பண்றேன். அதாவது இங்க கால்குலேட் பண்ற A முதல்ல கால்குலேட் பண்ற A-வை விட அதிகமா இருந்துச்சுன்னா நம்மளுடைய மாடியூல் கால்குலேஷன் முடிஞ்சு போச்சு. இல்ல கம்மியா இருந்துச்சுன்னா நீங்க மாடியூலை இன்னும் இன்க்ரீஸ் பண்ணி இந்த A முதல் A-வை விட அதிகமா வர மாதிரி பண்ணணும். I'll repeat, this is a place of confusion. If you are getting A here more than the A in step 1, your calculation is over. If your A is less than the first one, increase A, increase module, and get the value of angela pontidilla. Increase the module. If 3 mm vanduche 10 la make it 4 mm. அந்த மாதிரி பண்ணுங்க. 4 mm பண்ணி check the calculation of A. A வந்து முதல் A விட அதிகமா வந்துச்சுன்னா இப்போ வந்து இருக்கிற மாடியூல வந்து டேபிள் 1ல ரவுண்ட் ஆஃப் பண்ணிக்கலாம். டேட்டா புக் பேஜ் நம்பர் 8.2. டேபிள் 1 ஃபாஸ்டா போங்க. நெக்ஸ்ட் பேஜ் கீழ வாங்க. டேபிள் 1 இருக்கு. அது கீழ அந்த பாருங்க. Next, table 1. Yes. Here preference 1 பாருங்க, preferred 1. So standard module உங்களுக்கு நார்மலா இப்போ 2.7 வந்துச்சுன்னா take 3. Don't go to 2.75. Choice 2 ல இருக்கு 2.75 எடுக்கிறேன்ல போகாதீங்க. You take 3 only. If you are getting 2.7 or 7 or something like that, preference 1 ல 3 எடுத்துங்க. This is a standard module. You can go to presentation back. Okay, next. Step 4. Calculate phase width and recalculate design torque. Here, இப்போ நம்ம நார்மலி முதல்ல என்ன யூஸ் பண்ணோம்னா psi equal to 0.3 ன்னு அஸ்யூம் பண்ணோம். That is nothing but b by a. Now using this value, if you know the final a, இப்போ final a நமக்கு தெரிஞ்சிச்சு, substitute பண்ணீங்கன்னா you can get the value of b. அந்த வேல்யூ எடுத்துக்கோங்க. அதே மாதிரி கீழ இருக்குல்ல psi m equal to b by m, மாடியூல் தெரிஞ்சிச்சு, கால்குலேட் பண்ணுங்க, b ஐ கால்குலேட் பண்ணுங்க. இதுல எதுல எந்த வேல்யூ ஹையரா வருதோ அதுதான் b. I repeat, ரெண்டு கால்குலேஷன் இருக்கு, psi equal to b by a, psi m equal to b by m. இங்க நமக்கு a யும் m ம் ஆல்ரெடி தெரியும், psi யும் psi m ம் தெரியும். சப்ஸ்டிட்யூட் பண்ணும்போது ரெண்டு வேல்யூஸ் கிடைக்கும் b க்கு. அதுல ஹையர் வேல்யூவை அடாப்ட் பண்ணிக்கணும். இதை அடாப்ட் பண்ண பிறகு இந்த பேஜ் நம்பர் இப்போ நீங்க பேஜ் நம்பர் போக வேண்டாம் 8.14 15ல எல்லாம் அங்க இருக்கும், அந்த கேடிகே சூஸ் பண்ண வேண்டிய ரூட் எல்லாம் இருக்கும். அங்க கேடிகே வந்து அதுக்கு இப்போ எக்ஸாக்ட் வேல்யூஸ் ஆஃப் கியர் பாராமீட்டர்ஸ் எல்லாம் நமக்கு அவைலபிள். பிகாஸ் மாடியூல் we know, center distance we know, we know. கியரோட ஆல் parameters are known now. Because of that, we will get whatever we want. We can calculate from the page number 8.14, and you can get the actual values of KD and K. Normally, the product of KD and K will be less than 1.3. Normally, if we calculate பண்ற நம்ம assume பண்றது KDK product we assumed 1.3, but now when you calculate, this will be normally less than 1.3. Then you can proceed with once again the calculate MD, corrected MD you can calculate, then proceed. Next. This is check for compressive strength. This is a straightforward calculation. Only thing different here is the MD recalculated MD, corrected MD. The corrected MD put it, we have to substitute and calculate sigma c. See whether you are getting sigma c less than sigma c square bracket which was calculated in step 1. In step 1 we calculated sigma c within square bracket. That value is there, which will be around 5,000 or 6,000. Now you calculate, because the MD is now recalculated MD, you'll be getting a different value which may be less than 5,000. If they are getting the value sigma c less than sigma c square bracket, you say that the design is safe. Clear? Should I repeat? Okay, you go to the next slide. So this is check for bending strength. For bending strength, formula is once again straightforward formula, sigma b equal to I plus 1 divided by a m b y md, which is less than sigma b. A is center distance, m is module, b is phase width, y is form factor. Everything is known. Corrected MD is there. You will get a value of sigma b that should be less than the sigma b calculated in step 2. Normally, sigma will be around, for C48 will be around 1,600. Here you may be getting 800 or 900, which will be far less than sigma b. Then you can say that the design is safe. For helical herringbone gears also, those things are there. In parallel, those things are there. Next, very important in the design, if you don't make this simple sketch, you will not be given the complete credit. You'll be missing 3 to 4 marks, even if you do all the calculations. Very important. Here you can, whatever you can see is base circles are seen, pitch circles are seen. You can mark the center distance, mark pitch circle, mark base circle. You can also mark addendum circle if you can. And so 1 or 2 teeth in gear test as shown here. இங்க இருக்கிற மாதிரி இந்த ரெண்டு கியர் டூத் மட்டும் வரைஞ்சுக்கோங்க, the circles வரைஞ்சுக்கோங்க, அப்புறம் பக்கத்துல லிஸ்ட் பண்ணிக்கோங்க. What is the final center distance, what is the final module, what is the number of teeth in pinion, what is the number of teeth in wheel, what is the face width. If you mark everything, you will give the complete credit of marks. This makes the problem complete. Next. Now we have less serious things here. Actually, in your unit 5, you have the gearbox design now. So for gearbox design, you have to calculate the gear forces. You should know gear forces. So this is about which I was talking about in the initial slides. The normal gear is the F normal. This is the normal force. Normal force has two components. One is this is the radial force and this is the tangential force. This is a pitch circle. And for helical gear, you will have a different extra force. So for that only I have shown the table, sorry, page number 8.22, please over again. Last but one page. Past up to back one. Last but one. Oh, sorry, last page, last page, right. The பாருங்க down. You see here, tangential force, radial force, axial force. For Spur gear, you have tangential force and radial force. There is no axial force. For helical gear, you have tangential force, radial force, axial force. I was explaining in the beginning of the lecture. This is the disadvantage of the helical gear. Whereas in herringbone gear, that is also nullified. So that is the advantage of herringbone gear. So these things you can keep in mind. These forces are required for the design of bearings and design of shafts. When you make design for gearboxes in Unit 5, you can come back to presentation. Now, next slide. So we are going to relax. The design part is over. This is just some pictures. Externally meshing gears. Next. Internally meshing gears. We could have seen the mechanism machines, epicyclic gear trains and all. A similar the arrangement is here. Next. So this is just a helical gear sketch. Next. This is bevel gears. Set of bevel gears are shown. Next. Bevel gears machine drawing. This is from this is detail, used in detail. So actually here instead of center distance we have the cone distance. You might have already studied. This is the cone distance, which is replacing the calculation of the center distance. Next. This is a bitter gears. When we have the 45 degree and number of teeth same in bevel gears, we have bitter gears. Frequently the question is asked, what are bitter gears? Bitter gears are nothing but bevel gears with pinion and wheel with the same number of teeth and the reference angle 45 degrees. Next. This is a set of home gears. Normally the home will be made of cast iron and will be brass, and a lot of friction will be there. The gear ratio will be very high. For gears, we have traction ratios in the order of 4, but here it can go up to 25 or 40. But this is a self-locking drive which can be used for the hinges or the loading devices where the load will not retract automatically, and only in such places with low speed applications home gear will be used. And this is the end of the lecture. Now I am ready to clarify your queries if any.
Okay, participants, if you have any queries, please ask.
So the Sankar Subramaniam sir asked, is there any specific reason for center distance is maximum than the calculated in step 1?
That is actually we have to satisfy two things. One on the module stabilize பண்ணனும், A stabilize பண்ணனும். ரெண்டு ஃபார்முலால இருக்குறதுனால we are stabilizing one by one. First calculation A வச்சு stabilize பண்ணிட்டோம். Second ஃபார்முலால module stabilize பண்றோம். பட் அந்த module வந்து center distance support பண்ணாட்டி module திரும்ப increase பண்ணிக்கிறோம். Clear?
Thank you, sir.
Clear than
Yes, sir.
Yes, sir. Clear, sir.
Okay.
Sir, then in examinations, sir, sometimes they are asking based on the heads and below method, you have to design. Otherwise, you have to design based on the AGMA method. What's the difference, sir? So
this is the AGMA. This is the AGMA method, industrial method. The other one is mechanics. Other method is mechanics based.
Okay, sir.
Which I have not included in the presentation.
Yes, sir.
Sir, I have one small doubt, sir. Sir, apart from hello, sir. Sir, apart from normal design procedure, what we are having in PSD data book, as it was followed from 1964 to till now. But in today's latest software like EdgeCam or some CAD softwares, we can find that if by giving the value, it is directly creating gear, right, sir? Whether they are following the same kind of design procedure what the PSD data book is following, or whether is there any other kind of different procedures to follow this gears, whether anything it is available. That's my question.
Actually, the softwares work on mechanics based. They can sense stresses and strains. So with the allowable stress values and factor safety what you give based on that it will design.
Yes, sir. But what happened is long back, I think 2 years back, I tried with the software. I tried to compare it with the software and normal PSD data books. What I got is actually by using the PSD data book, when I tried to solve the problem, I got the design as safe. But by using that CAD software, I think that is EdgeCAD. That is one software. So by using that software, I checked. By using the same pitch, same number of teeth, all those things I have given and checked. But it was showing that design is failed. So that's why I asked the question.
I'll tell you how to do. Here, whatever the safety factors KD, KL, these are all design things. Hello.
Okay, sir. Okay, sir.
A large number of factors we are taking. KD, K1.3 எடுத்துக்கிறோம். அப்புறம் service factor எடுத்துக்கிறோம். In the service factor they will amplify the information. We are making safer and safer. If you avoid those factors and do the design plainly without safety factors and all, you will get actual stress level, which you can check from the ANSYS software or some other software.
Okay, sir. Okay, sir.
Avoid taking the safety factors. So that is the way by which you can take out the error.
Okay, sir. Okay, sir. Thank you. Thank you.
Participants, any other questions? So if you have any questions, please unmute your mic and ask the questions to our presenters. Okay.
So there is, sir, there is another one question, sir. I think it is, maybe it may not be relevant, but I just would like to ask it to you. I'm asking from my alma mater, sir. Actually, what the thing is, the design procedure, everyone knows. As a faculty or as a student, if they are referring the book, means they will know everything, each and everything. We can refer the PSC data book and we can extract all the information. But what I personally feel is, after designing all those things, we were not able to draw this in a paper. I think you understand what I would like to say. We are knowing all this center distances, module, everything we are finding out, but we were not able to draw. If someone asked to draw this diagram, I mean this spur gear pair or a helical bevel gear pair in a paper means, we could not able to draw. There is some problem, as there is some involute gear profile, some different parameters are there. So I tried it once after getting the information from the PSD data book, after getting the design is safe and all. I tried to draw this in a paper, but I failed. Is there any way to draw, or is there any tutorial available in the online to get such kind of things?
So actually, I am not used to actually drafting packages. Actually, I am with conversant with the analysis packages, but ANSYS package. Okay, but the problem is you cannot in this era. It is not worthwhile for us to go to the invalid profile generation. You have to only go to the dedicated software wherein invalid profile will be there. Only if you use that, you will get the actual gear.
Okay, sir. Okay, sir. Okay.
Because there is there are a lot of corrections, Actually, in actual teeth, the gears, the fillet radius is there. Addendum will not be 1. Dedendum will not be 1.25. There are a lot of corrections practically there. If you go to the relevant IS code, BIS code, you will see many things there. If you take that, you can run.
Okay, sir. Okay, sir. Thanks.
Okay.
Participants, any doubt you can ask in
Sir,
the
sigma B, sir, sigma B and sigma C values வந்து டைரக்டா வந்து அந்த இதுல இருந்து எடுக்க கூடாது அப்படிங்கிற மாதிரி சொன்னீங்கல்ல சார். ஆக்சுவலா வந்து மெட்டீரியல்ஸ் வந்து சேமா இருந்துச்சு அப்படின்னா எடுத்துக்கலாமா சார்? எப்படி சார் அது எப்ப வந்து டிஃபர் ஆகும்?
அத வந்து டிஃபர் ஆகுறது இல்ல, ஒன்றும் பெரிய டிஃபரன்ஸ் கிடையாது. தேர் இஸ் நோ எரர். பட் அந்த ஸ்டெப் நம்ம பண்ணணுங்கிறத எக்ஸாமினர்ஸ் எதிர்பார்க்கறாங்க.
ஓ, ஹார்னஸ் வேல்யூ எல்லாம் போட்டு சிபி ஹெச்ஆர்சி வேல்யூ எல்லாம் போட்டு பண்ணணும். ஓகே சார்.
எஸ், பண்ணணுங்கிறத எக்ஸாமினர்ஸ் எதிர்பார்ப்பாங்க. எஸ், தட்ஸ் தி திங்.
ஓகே சார். தேங்க் யூ சார்.
ஓகே, ஓகே.
So Sangara Subramaniam sir, what happens if you go for choice 2 in selecting module?
Choice 2. அது இண்டஸ்ட்ரியல் பிராக்டிஸ் இல்ல. இண்டஸ்ட்ரியல் பிராக்டிஸ் இல்லாதனால அந்த கட்டர்ஸ் may not be available. இப்போ டிசைன் பண்ணோம்னா அது ஃபர்ஸ்ட் பிரெஃபரன்ஸ்ல இருக்கிற கட்டர்ஸ் எல்லாம் மார்க்கெட்ல அவைலபிளா இருக்கும். செகண்ட் பிரெஃபரன்ஸ்ல இருக்கிறது இல்ல இருக்கணும்னு அவசியம் இல்ல. That's the reason. It may be rare.
Okay, sir. Okay. Thank you, sir.
Sir, thank you. So, any questions from participant side? Any other questions, sir?
Sir?
Yes.
Sir, mention some simple difference between involute and cycloidal teeth profile, sir. Simple difference.
Hello? கொஞ்சம் ஆடியோ மியூட், இந்த வீடியோ மியூட் பண்ணிரு. நெட்வொர்க் இருக்கு. ஹலோ.
சார்.
சொல்லுங்க தம்பி. எஸ் சார்.
Some mention some simple difference between involute and cycloidal teeth profile, sir. Some simple difference, sir. Involute and cycloidal teeth. கேக்குறேன் சார். Some simple difference between.
சொல்லணுமா நானே?
Sir, he is asking about the difference between cycloidal teeth and involute teeth, sir.
Okay.
Simple difference.
Cycloid is generated from the circle. It is actually involute. Involute is defined as the point raised by the end of thread which is unwound from a circular farmer. அது உங்களுக்கு காமிச்சேன். அது ஒரு சர்க்குலர் ஃபார்ம்ல இருந்து ஒரு நூல் கட்டி வச்சிருக்கோம்னு அசியூம் பண்ணிக்கிறோம். அந்த நூலோட டிப்பை வச்சுட்டு நம்ம அப்படியே டைட்டா வச்சுக்கிட்டே அன்வைண்ட் பண்றோம்னா the end ஒரு லைனை ட்ரேஸ் பண்ணும். தட் இஸ் ஆக்சுவலி இன்வல்யூட் ப்ரொஃபைல். இன்வல்யூட் ப்ரொஃபைலுக்கு ஒரு என்ன ஃபீச்சர் அப்படின்னா, சென்டர் டிஸ்டன்ஸ் சேஞ்ச் பண்ணா கூட வெலாசிட்டி ரேஷியோ சேஞ்ச் ஆகாது. இட் இஸ் ஹைலி அட்வான்டேஜஸ் ஃபார் கியர்ஸ். திஸ் இஸ் தி சைக்ளாய்டு தெரியும். சைக்ளாய்டு வந்து when a circular thing is rolling over a straight generator. Graphics படிச்சுக்கோங்க. சைக்ளாய்டு, சிபி சைக்ளாய்டு, ஹைப்போசைக்ளாய்டு எல்லாம் படிச்சிருக்கீங்களா? So when a circular thing rolls over a straight line, the point raised by on the periphery of the wheel gives you the cycloid. Cycloid gears, the advantage is it has a base, a wider base, therefore it is stronger and its failure will be rare. That's all. Whereas the center distance drawback will be there.
Okay, sir. Okay. Okay, sir. Okay. So, any other questions, sir, from participant side? Okay, sir. Formally, I conclude the session, sir. So, first of all, I thank our management because always they are supporting the knowledge enhancement programs. This time also they are supporting to conduct this technical seminar through this online platform. Then I would like to convey my thanks to our principal sir and vice principal sir to give this opportunity to conduct this program. Then it's my immense pleasure to submit our special thanks to our resource person for today's webinar session. So we have given the only one topic, that is design of Spur gear and helical gear only, sir. But he explained so much of basic things about the different gears. Really, today's session was very wonderful and useful to the participants, sir. Thank you, sir. I can.
Okay, sir. Thank you.
Thank you, sir. Then
I'm
I
sorry.
can, sir. Yes, sir. Sir.
I'm sorry for the interruption caused by me because of the system problems.
So no problem, sir. Always it's happening, sir. It's a online problem. It's a new to us, sir.
Okay, sir. Okay.
Then I convey my thanks to the team behind the RIT Mechanical Care Center, because without them, the YouTube live stream is not possible. Not but least, I am very much thankful of our participants for attending and listening the webinar patiently. Thank you once again, sir. Thank you, sir. Thank you.
Okay. Thank you all.
Thank you, sir. Thank you, sir.
Thank you all.
Thank you, sir. We may leave, sir. We may leave. We may leave from
yes,
the.
yes,
sir. Thank you, sir. Thank you, sir. So, if participants completed their online details, attendance details, you can leave from the session. So, only one announcement. Today's tomorrow morning session 10 to 11:30 will be handled by Mr. P. Suresh Kumar, design of bevel gear drives. The afternoon session already we have planned to conduct the design of arm gear drives. So instead of that, the session will be taken by me. That is design of gearboxes, and Gururaj, design of gearboxes. So the design of arm gear drives session will be conducted on 18/6/2020. Thursday only, right? So this is the simple modification. So in that schedule, right? Please follow. So tomorrow also I will announce, right, in front of all the participants. Thank you. So if you have completed your attendance details, you may leave. No problem. Sir, Venkatesh sir, any other thing, sir?
No, sir. Once again, we thank you, Mr. Jebin sir, for
yes, sir. Sir, really, sir, I forgot, sir. Very, very sorry, sir.
Okay, sir, no problem.
Thank you, sir.
Sir, Jebin sir, sorry, sir. Okay, sir. Thank you, sir. His help is very great, sir, today.
So dear participants, so every videos we are uploaded in the RIT Mech CAD Center. So if you need any topic, means you have to judge us in the RIT CAD Center. So we will teach you again. Okay. So
all the recorded videos are uploaded in that YouTube channel only, sir. So at any time you can view that videos. So additionally, we are updating day by day so much of teaching videos. So if you watch that videos, you can enhance more knowledge based on the mechanical engineering and other engineering also.
So once you subscribe to RIT Mech CAD Center, means every time we are uploading new videos, means so from your side the notifications will come. So once you have to subscribe our channel, so you get a new information from our side.